Can everyone hear me all right? Awesome. So yeah, my name is DanielBohannon, and this talk is Invoke obfuscation, PowerShell obfuscation techniques, and how to try to detect them. Just a little bit about myself. This actually is me. This is what I look like on the internet. I'm currently an incident response consultant with Mandiant. I've been there for the past year and a half. Prior to that, I spent 5 years doing operations and security for a national restaurant franchise in the US. I'm currently based out of Washington, DC. This is my first time to Belgium, and it's a beautiful country, and just really honored to be here. So just really excited about that, so thank you. Here's my Twitter handle and then personal blog. And yeah, let's dive right in. A quick disclaimer, there's a lot of information here that I feel is important to cover to really just kind of get the gravity of the topic. So there's not going to be a lot of memes. There'll be a few at the end, but hopefully you'll find it interesting enough that you can forego the fact that there really aren't that many cat pictures in here. So a quick outline. First, the motivation. Why did I even start looking at PowerShell in this way? Preparing your environment for investigating PowerShell, much easier said than done. We'll then look at an in-depth example of obfuscating syntactically the most common syntax that we see for what we like to call the remote download cradle that we see attackers using all the time. Then we'll look at some more methods for obfuscating PowerShell commands, more of like a string manipulation way. And then we will look at encoding, decoding techniques. What are attackers actually using? And then also some more weird encoding and decoding techniques that perhaps we as blue teamers should be aware of and be looking for. Then lastly, we'll look at launch techniques, interesting ways to launch PowerShell such that it may surprise you if you're looking for command line arguments for all the stuff we're going to talk about. There's some shortcomings we need to become aware of so that we're not making bad assumptions of even which processes we're looking for PowerShell commands in. And then at the very end, we'll do a quick demo of a tool that I built called Invoke obfuscation, which basically wraps all these obfuscation techniques into one place so that you don't have to struggle for hundreds of hours like I have in finding them, getting all the tick marks and stuff lined up in the right place, getting layers of escaping correct. It's all in one place in one tool so that you can test your own detections against these techniques. So motivation, why, as a security person, why should we care about PowerShell? Well, attackers love PowerShell, and it's everywhere. There's really not many investigations that we are a part of where PowerShell is not used at some point in the investigation. It's native, signed Windows binary, available on Vista and later. And again, attackers, script kiddies, everyone's using it. And when it really comes down to it, if you don't have, at a bare minimum, command line arguments, I really don't know, there aren't many other places to look to see, is malicious PowerShell being run in my environment? So that's kind of the bare minimum. We'll look at that in a second in terms of setting up your environment to investigate these attacks. Again, we see PowerShell being used at every part of the attack lifecycle. There's just so many frameworks that are coming out that are just so beneficial to red teamers, and some more tools that are coming out that are beneficial to blue teamers as well. But we see PowerShell launched from scripts, registry, link files, WMI, PowerShell remoting, all these places. And at the end of the day, as defenders, again, a lot of people and a lot of tools make the assumption that we can detect this by looking at arguments for PowerShell.exe. That's a bad assumption to make. And I'm not just talking about what collectively has been kind of dubbed unmanaged PowerShell. We'll touch on that very, very briefly, but that's not even what I'm talking about. So the current state of detection typically is looking for, on the command line for PowerShell.exe, looking for certain strings that attackers like to use. Typically, we see these two, encoded command, followed by base64 encoded blob, or this syntax for, again, a remote download cradle. So remotely downloading a script and executing it entirely in memory, nothing hits disk. However, for both of these, it's super important to realize that it's not the only way to write these exact functions, and it's also not the only way to accomplish the task that the attacker is using these functions for. And we'll look at these. So for me personally, my mission for the past year of research has been to know what's possible, to know the options. And I think that's important for all of us as defenders, and as red teamers even, to know what options are available to us. And so basically, I looked at our current tool set and how we were detecting malicious PowerShell. And not being a red teamer, I started to talk to some of our red team guys and say, hey, like, what are you guys using? Let me play around with some of these tools, and how can I get around what I know our current detection is? So as I found a way around our detection, I then added that to our detection. Found a way around that, added it, and for the past year, this has been my life. Basically playing this cat and mouse game with red team, blue team internally, and coming up with these obfuscation techniques, many of which we have not seen in the wild, but recognizing that syntactically it's possible. PowerShell is such a rich language built on top of .NET, and you can interact with a lot more than just that. So how do we know our options to make sure that we're not missing something obvious or even very obscure? And this is why I share this knowledge with everyone here in hopes that we'll all walk away realizing that it's a lot more complicated animal than we may have initially realized. And obviously, as we start to come across these techniques, we started looking for them in our investigations. Attackers are obfuscating a little more than we may have initially thought. So as we go through this, my goal for my fellow blue teamers is that, again, we be aware of what's possible so we can make better assumptions or get rid of a lot of bad assumptions of what we think our current detections are doing or not doing. For the red team, I hope that as red teamers, that you are responsible red teamers, and I hope this will basically make your red team efforts more successful for the purpose of making the detection better for your client and helping them figure out how do we better detect what you just did. And then again, just basically drawing attention to this tool that I hope will really make it easy for anyone, blue team or red team, to basically input a PowerShell command or a script and then apply these obfuscation techniques very quickly, very easily, to be able to run it against your own organization to say, did we actually detect this? So preparing your environment. This is hilarious. One slide, the hardest part of the entire talk. This is not an easy feat, but a very broad, just quick coverage of this. Again, if you don't have command line arguments, whether it's some kind of real-time agent or event logs, like if you have your updated 4688 with command line arguments, or even something like sysmon EID1, command line arguments are crucial if you don't have anything else. Very, very important. In addition, there's great open source tools out there like Uproot IDS that, again, if you don't have a way to get all of your logs in one place, then that's really unfortunate, but there are other options that you can use that are free to get that information. The last bullet point, PowerShell, over the years, has come up with really, really fantastic logging. My colleague Matt Dunwoody has this blog post here I'd really recommend you check out that basically outlines what you get with each version of PowerShell and the different logging, module, script lock, and transcription logging. Even walking through the example of, say, like Invoke and Meecats running. What do you have without these logs? What visibility do you have with these logs? Really, really helpful to kind of make the justification of why should we go around updating PowerShell and updating .NET to get these logs. Well, hopefully this talk will convince you that it's actually really, really important to get those logs. It doesn't make detecting obfuscation and malicious PowerShell easy by any means, but at least the evidence is there, and we as a collective group of defenders can start to at least have the data available to look at novel ways of detecting this kind of activity. So that's preparing your environment. So let's look at an example. This remote download cradle, we see this all the time. It seems to be the most popular syntax that attackers use. It's the syntax that a lot of well-known tools generate when you're generating PowerShell payloads. So let's go through a little exercise. We have our red team command, our attacker command at the top, which again is just remotely downloading this content from this legit, totally legit bit.ly. It is then invoking in memory that script so nothing ever hits disk. So as a blue team, together, let's figure out if we're monitoring command line arguments for this, then how can we detect this remote download cradle? Well, we could say, okay, if we see invoke expression and we see new object, system.net web client and download string HTTP, this would catch that download cradle, right? So let's start breaking assumptions. Why would this be a dangerous trigger or signature to write for this kind of activity? First, system dot. Whenever you see this in PowerShell, it's referencing a .NET class, and it's not necessary. PowerShell does a lot of stuff behind the scenes to automatically prepend or append certain pieces of information looking for what they assume you're looking for. So system.net is not necessary, so we're going to remove that from the attacker command and from the trigger. Next, the URL. This is a string object. You can concatenate this in line. You can also add white space. You can use single quotes, double quotes. You could also set it as a variable if you wanted to. So we'll just remove HTTP from the trigger. So download string. Download string is it is a member of the net.webclient.net class. However, it's not the only one. It is the most common one that we see, but there's actually a lot of options available. We have download string, file, and data as kind of like the larger groupings, but then you have all these other additional strings that can go after it, task async. And download file will download to disk. A lot of commodity malware uses this, but download data we actually have seen used before, and it's just downloading it not as an expression, but as a byte stream. Again, nothing hits disk. So maybe we'll just say, okay, if we see .download, that'll be good enough, and it'll catch all those options. Everyone on board? All right, so .download. Now the parenthesis. Why might this be problematic? Well, new object net.webclient we can actually set as a variable, and some tools do this. Typically they'll call the variable WC or something like that. But then you just have variable name .download string. So let's get rid of that parenthesis. So next, how could the dot be problematic if we're including this in our signature, in our trigger? Well, how can we obfuscate a member token? So being stubborn and very OCD, I just took every element of the command after I tokenized it with the language parser in .NET and said, okay, for each of these objects, what are ways that I can just mangle it or manipulate it such that I can break what I think are good detections to make it better detections? So I found that you can throw single quotes around member arguments. And not surprising, you can throw double quotes around it. Now I want you to look really closely at the download string up there, and I promise you this next slide, this actually works. That. Just a little tick mark. So why does this work, and why does it matter? Well, the tick mark is the escape character in PowerShell. Typically, you see it before a 0 for null, or before these other 7 characters for like new line, backspace, stuff like that. A little alert, beep sound. But whenever you have like a really long command, like maybe like a really long if block or something, you can actually wrap it on multiple lines and end the line with a tick. And you're literally escaping the new line character that's there that you can't see. So if you throw a tick mark in front of something that has no special meaning, totally cool with that. Now, why does that matter from a defender perspective? Well, we can throw it in front of all these characters as long as it's not one of these special characters, right? That sucks. And then also, if you just like uppercase those characters, it's good. Tick marks. Doesn't matter what character it is. If I have double quotes, I can put tick marks in any place in a member argument. And this sucks from a defense perspective because those tick marks make it through to the command line arguments as well as to PowerShell script block logging. Now, if you've never seen PowerShell script block logging, it will basically, every time that you encrypt or encode or wrap obfuscation around a command, it will log every single invocation and every single layer. It'll peel back every layer of that onion. But when it gets to the final one, if it's not actually being passed into an invocation function, then it reports it as is. So this screenshot at the bottom is actually the final script block log for this command. The ticks are still there. The concatenation is still there. So if we make an assumption that all the obfuscation is removed in script block logs, that is not true. And we have to be aware of what's possible because we're going to really make bad assumptions if we start to think that this will get us everything we want. One approach to this is to say, okay, well, let's just remove special characters. That would actually work here. We can remove the ticks, the quotes, the plus. We can even remove white space and look for those strings. In this example, it would work. However, one of the functions I added to the tool is anytime we convert something to a string, we can actually do literally any string manipulation that we want. And there's a nice little thing called a -f format operator, so that now you can basically chop up a string and put it in any order you want, and then over on the other side of the F say, this is the ordering I want, the third element in the first and the 0th. So then if you're removing special characters, you just get this garbled string, and it never shows up like you would expect. So as a defender, we can like start to do crazy regex to try to look for ticks, but now that we know we can also reorder everything, it's hopeless to look for every possible way you could write download. So as an indicator, let's just remove that. Another thing to be aware of, again, knowing your options. We talked about download string, file, and data. There's also one called open read, which also doesn't hit disk, and we have seen that one used once before. Again, it's pulling down a byte stream you have to deal with a little bit differently before you invoke it, but still works. The string as a member, you can also, this is slightly different between PowerShell 2 and later versions, but just in general, you can treat a member as a string if you add a .invoke member afterwards. And again, you can start to reorder all these components and just really make things a mess. So let's remove that from the indicators. Net.webClient. So this is referencing a .NET class, but syntactically it is an argument to the new object command. So from an argument perspective, there's a lot of options we have. This is pretty simple. We can throw double quotes and tick marks like we did before. We can throw parentheses around it and then concatenate it in line or set it as a variable or reorder it any way we want. We can also chop it up into however many little variables we want elsewhere in the command and then piece it together. And again, if you're removing special characters, you're never going to see net.webClient anywhere in here because of the way that we've chopped it up. So we'll just go with the first option here. Keep it simple. So new object. So the remaining two things, invoke, expression, and new object, they're both commands. Now, if you've ever dealt with PowerShell, dealt with is a hard word. I love PowerShell. I didn't really say that about me at the beginning. I'm obsessed with PowerShell, and I hope that people will fall in love with it as much as I have. But just be aware of the flexibility of it so that we are detecting when it's being used nefariously. When you start using PowerShell, you'll realize there are so many options. There's so many aliases for commands. It makes it really easy if you've only done, say, like batch scripting, to then come into PowerShell because dir still works. If you're a Linux person, ls still works, or you can use the more proper PowerShell get child item or GCI, options like that. So when I got to new objects, I said, okay, this is a command, but there's actually no aliases for this command. So this should be like a really solid indicator. And I was really excited about this. However, PowerShell is such a rich language, sometimes you literally forget what commands are available. And there's this great feature called get command, which is a command itself. So you run get command and it shows you all the commands that are available. So let's say, I know I have a command that's like new-p something. You can do get command new-p wildcard, and there's your commands. Now with PowerShell, it's not returning text. These are PowerShell objects that are being returned. What does that mean for us? That means that as an object, we can invoke that object. So the output from get command new object, if we invoke expression that, it's the same as calling new object. And since we're dealing with a commandlet, we can use invoke expression, or we can use invoke operators, an ampersand or a dot. So remember the wildcards? We can search for commands. This whole invoke trick works as long as you're only dealing with a single command. So that means that that's new object. That. This is still new object. And how do you think this appears on the command line and script block logs? Just like that. So how many of us are looking for get command on the command line? Like, should that really legitimately be happening? Well, if you do, and I would recommend you look for it, keep in mind that it also has an alias of GCM, and it has an undocumented alias of command. Now, why does command work? Well, again, if you keep in mind, PowerShell is often behind the scenes adding or prepending or appending different strings. So it'll actually prepend a get dash to pretty much anything you type to say, is there a commandlet named this? Turns out there is, so command works. Now, if you want to start triggering on literally the string command showing up on the command line, you better watch out, because it's a ripe opportunity for false positives. I do know from experience. You can see dash command as an execution argument. So again, when you're starting to build out regexes and search terms for this, you'll probably burn yourself, just like I burn myself a lot. But again, we can't let any one of these fall through the cracks, because that could be the one the attacker uses to get around our detection. In addition, instead of using the wildcards, we can treat new object as a string and do all the same string manipulation stuff that we want, set it in variables, chop it up, you name it. In addition to get command, GCM, and command, we have PowerShell 1.0 syntax. Now, if you are a red teamer and you're not spending a significant amount of time on poshcode.org looking at PowerShell 1.0, there are some real gems out there for a lot of different reasons you'd probably be interested in. I'll leave that for a later time. But basically, this execution context.invoke command, we have get command or get commandlet. If we want to use wildcards, we can use get commands, get commandlets, or we can do this weird combination of get command name, so on and so forth. So again, these are all on the slides, which will be published after the talk. And you can look to that syntax to make sure, are we looking for this? Do we see this in our environment? So we'll just go with the first option. Now, it gets even better, because that was all the stuff we could do with get command. Well, we can also do the same stuff with get alias. It just works with the alias name, not the full command. So again, get alias, alias gal, more things to add to our list of stuff to look for. So that's a bit more complicated than we thought. We can always just throw tick marks in front of any commandlet that we want. And there's this amazing thing called splatting. Now, splatting allows us to literally take an invocation operator or invoke expression and then take the commandlet name and treat it as a string. So now we can take our new object command and literally chop it up into as many variables as we want, or again, use the format operator or bitwise XOR it, ASCII encode it, whatever you want to do, and it will basically resolve that and then invoke it as a commandlet. Now, when you do stuff like this sucks as defenders, right? Because we don't see the commandlets we'd expect to see on the command line or even in script block logging. But if we have module logging enabled, we will see that parameter binding. We will see new object was run, and it was passed an argument of system.net.webclient. So a very small example of why PowerShell's logs are amazing to have. But also keeping in mind that there's no one single log that has all the answers. It's spread out in different places. But this is something that we have to look at and be aware of and deal with as defenders. And it's way better than nothing. Really, really good logs. Can't say that enough. So we can try to regex all the things, or maybe just give up on this as an indicator. So we'll just remove it from this example. So we're left with invoke expression, which is actually a freaking good indicator. If you're not looking for invoke expression or IEX on the command line, you're missing like most of the stuff out there. On the command line, it is a pretty unusual thing to see. But how could this be? If we are that defender and we're looking for those things, then what's problematic about that? What assumptions can we make about invoke expression that will burn us? Well, it has the alias of IEX. Order actually doesn't matter. We can IEX an expression, or then we can basically pipe an expression into IEX. Tick marks. Again, it's a commandlet. We can do that. We can do splatting. And then there's this cousin of invoke expression, invoke command. Now, typically, invoke command is used if you want to run a function or a command on a remote system or a list of remote systems. But if you don't specify a remote system name, it runs locally. The biggest difference between invoke expression and invoke command, besides the remote run ability, is invoke expression is expecting an expression, a string, and an invoke command is expecting a script block. We'll see in a second why that's important. So again, invoke command has an alias of ICM. It then has the invoke operators of ampersand and dot, and it has this great dot invoke member that we saw earlier in the member obfuscation. So let's add this to our indicators. Now, do you see anything that would be maybe really problematic if we're keying off of any time we see an ampersand or a dot? Does anyone want to run that regex on their environment? I wouldn't recommend it. So this was frustrating when I first saw this. It's like, well, how can we remove false positives from this? There's no way we can look for these two characters showing up. In addition, there's PowerShell 1.0 syntax. It does the same thing. Invoke command, invoke script. This will actually handle an expression or a script block. You don't have to even change the syntax. It handles both. And it does some sneakier stuff in the event logs as well. So something to be mindful of there. So we can throw tick marks around everything. That's great. But again, what about this ampersand and dot? Like, how in the world are we going to remove false positives from this example? Again, we're dealing with script blocks here, right? So a script block is not a string. It is usually denoted by curly braces. So we could say, okay, if we see a dot or an ampersand, and we also see open close curly braces, then we're dealing with a script block, right? Most of the time. However, we can convert expressions to script blocks. And there's two ways you can do that with the script block create.net syntax or PowerShell 1.0 again, new script block. This is great. PowerShell 1.0, awesome stuff. And for every one of these, we can obfuscate it 6 ways from Sunday. And at the very last step, after we wrap our command around any of these invocation operators, our entire command that we just worked so hard to obfuscate, it's a string now. So we can literally obfuscate all the tokens, we like to think of like layer 1 obfuscation, and then we can just wrap it around invocation, and now the whole thing's a string. Now keep in mind, each of those layers will be logged in script block logging. But from a command line perspective, now the entire command's a string. So now I can form an entirely separate layer of obfuscation at a string level on this command and make it really crazy on the command line. Again, you can obfuscate the .NET commands just as easily, and I'll leave those in in the slides for you to check out later. And there's slight differences, even in type obfuscation, between PowerShell 2 and 3 and later in terms of some of the things you can do. Typically, direct typecasting is what you'll see. That's the obfuscation that's in the tool because it works across all versions, but there are some differences in type obfuscation. So that could be maybe what we try to do to detect this, or we can just kind of give up because that's the command that we started with and it still works. That's what it looks like on the command line and script log logs. So, crazy regex? Not really. And this is just one example. This is the new object.net.web client example. So what other options are out there? Just from a language perspective. Again, PowerShell is just fantastically rich. So we looked at this example. If you're dealing with PowerShell 3 or later, you have invoke web request or IWR, as well as invoke REST method IRM. Invoke REST method. You can just call the .NET method straight up. And again, that system dot, not necessary. You don't need that. But net web request, HTTP web request, and we've seen these used. And again, with these typically you're dealing with byte streams. So again, you have to convert it from a byte stream before you invoke it as an expression, but it's possible. So let's say as an organization, you're super aware of obfuscation, and it sucks for detecting. You're also aware that there's a lot of ways to do this, remote download syntax. So you're aware of your own abilities as a human to, like we don't know all the answers, right? So why don't we do something a little different? It's so good to attack a problem from many different angles. So why don't we say, okay, let's monitor network connections. Maybe we have sysmon. We're looking at our EID3s, which basically pairs a process execution with a network connection. So anytime PowerShell.exe makes a network connection, I want to know about it. So as a red teamer, what might you do to get around that? Well, if you have access to a box, maybe you open Notepad, and then you go to open a file. Instead of a file name, what if we just put in a URL to like invoke Mimikatz or something? We opened that file, and Notepad just went and fetched our contents. Now, how can we automate this with PowerShell? Well, there's this great class called SendKeys that .NET has. And what we can do with that, what this example does, is PowerShell starts Notepad, and then sends it a Control-O to say, go to the Open tab, and then types in the URL, hits Enter, waits a second, and then it sends Control-A to select all, Control-C to copy all, and then the last portion rips it out of the clipboard and executes it. And PowerShell never made a network connection. We just got around that defense. Are we looking for PowerShell using SendKeys? There's a lot of crazy stuff you can do with that. And the great thing about this is that all this stuff on the command line, we're actually not even calling any invoke expression. That literally just happened with the enter command, the little tilde or curly brace enter, several different syntaxes you can use for that. But now we didn't even have invoke expression because that was handled by the interactive enter. As with anything in PowerShell, typically when PowerShell makes it easier to do something, it also provides better visibility to us as defenders. So in the SendKeys example, every step with PowerShell, you could do just calling .NET directly. And when you do that, if you'll notice this little void at the beginning, if you can accomplish your task with that void at the beginning, or with, say, piping to out null, reasons you may not want to do that if you're trying to stay quiet, but it's an option, or just setting a variable before whatever you're calling, it actually doesn't even show up in the PowerShell logs. So again, as a red teamer, there is value in going straight to .NET, especially if your target has these PowerShell logs. And as a defender, we need to realize there's a lot of ways to skin that cat. And we need to be aware of them and looking for them. This is really, you can do this with any tool that has an open file functionality GUI, right? PowerShell ISE is nice because you can just, pull down the payload and then send an F5 and it executes it. You don't have to worry about the whole clipboard issue. Turns out this actually isn't entirely in memory though. So as a defender, this actually does hit disk. It hits disk in temporary internet files. And in most of the cases, it actually retains the original file name. Excel is a little bit different. But there's some great forensic artifacts this leaves behind. Again, you have now PS1 script content sitting in temporary internet files. There's other things in the registry that change. Or think about recently open documents. Now you have one that's an external source. So there are places where you can pull that kind of evidence, but Office 365, it's It's doing a lot of network connectivity, so maybe that's not too unusual to see in your environment. Again, it all depends on your environment and what you'd expect to see and not to see. It's just important to be aware and to be looking. So send keys, that's kind of a fun example, but it's really sloppy. Like, I'd hope most users, if they see Notepad popping up, that they would call and say, hey, something really weird's happening. So what's like a slicker way to do this? Well, COM objects are super, super powerful. So why don't you just have PowerShell, interact with, I don't know, Internet Explorer and say, hey, Internet Explorer, you go fetch my payload. Then I'm going to query out the HTML, whatever elements I want to piece together my command and invoke it. Is it weird to see Internet Explorer making network connectivity? Like, Notepad's weird, right? But like, it's freaking Internet Explorer. It's what it's supposed to do. Another great thing about this is that it uses the default user agent string. So are we looking for this syntax? What other indicators are there when PowerShell starts interacting with COM objects, especially something like Internet Explorer? And it can do this with so many things. Word, Excel, PowerPoint, OneNote, a lot of options out there. So many COM object possibilities. I still have a lot to learn about COM objects, but I've seen enough of these examples in my testing that it's pretty cool. So let's look at some more obfuscation. All right, we've looked at token level obfuscation. We've looked at syntactically, there's a lot of options with PowerShell, and there's a lot more that we're going to look at in the next section. But again, we talked about after we obfuscate the tokens, we can treat the command as a string, and then we have string manipulation at our fingertips. So we could do something like reverse the entire command, and then unreverse it on the command line. So now any great indicators we had, they're all reversed. Lots of ways you can do this with PowerShell, .NET syntax, .NET regex class. Again, so many ways you can do this. You can basically start to put in garbage delimiters all throughout your command, and then on the command line, what you do is just say, yeah, let me just like split on those delimiters and then rejoin, and then invoke what's left. A good way to break up what's on the command line. You can do a very similar thing with replace, just put in delimiter strings and then replace it with nothing, and then invoke that. PowerShell's -f format operator. This is the nice feature at the bottom where you can basically start to chop up substrings and then put them in whatever order you want back on the left side of -f. This is what's really problematic for removing special characters from script block logs and looking for key indicators. You can concatenate strings, a million ways to do this. Again, all of our indicators we're basing off of, we can treat that entire command as a string as long as we're passing it back into an invocation function. So we can't count on anything really looking like we'd expect it to look like on the command line, or even in the last layer of script block logs. So how do we detect some of this stuff? Who all's blue team in the room? Who else blue team? A couple? Red team? All right. Everyone else is APT, I'm assuming. So yeah, I mean, are you feeling like frustrated? Because the more I found this stuff, I was like, oh man, this is awful. This looks kind of weird though. Like when a human looks at this, it doesn't look right. But if we're relying on rules, then how can we start to detect some of this stuff? Well, we could look from a string perspective. We could start to look for some of these string manipulation functions, right? Like reverse, replace. But we need to be mindful of little one-offs. Like if you're looking at -replace for .NET, there's also a -c replace for case sensitive. So there's all these little nuances that can be used. And again, all these nuances I've put into the tool so that they'll all be randomly selected. So that if you run it enough, you'll hopefully find most of these combinations actually being coaxed out of the tool, but you'll never get the same output twice. But there's actually some legitimate stuff out there that does use this on the command line. And that's where it becomes challenging for us because we have to make indicators that work across all of our clients. But from an operational perspective, you can be a lot more honed in on your environment. So definitely an advantage there for this kind of stuff. You can look for high counts of certain characters. Like how many $signs did you expect to be there if you're chopping up the command in a lot of little variables, right? Like that's maybe a weird thing to be sitting on the command line. Or maybe semicolons. Maybe there's too many individual commands on the command line. Or like tick marks. Like how many tick marks do you normally have on the command line? That should be like kind of rare, right? But got to keep in mind, there's always different ways to do this. For variables, we can actually set and use variables using nothing but the get variable and set variable functions. A $sign never appears anywhere. If we want to execute multiple commands without there being a semicolon, we can just do one pipe and then put as many script blocks as we want after that. And for each one, it'll be executed. Or for string concatenation, again, you don't even need pluses. You can just throw it in double quotes, and it'll concatenate just fine. In addition, if there's any character that is problematic and you know that your target is looking for high counts of these characters, just do on-the-fly ASCII conversions. So at the bottom here, string char59, that's a semicolon. So we basically say, let me go deliver everywhere I want a semicolon in my command, and then before I actually load it, I'll just swap it with the actual value of the ASCII 59, which is a semicolon. You're good to go. So again, as a defender, are we looking for these types? For string and char, or two string or two char? Like, should we be saying that one command line? Is that weird? I referenced this earlier, there's slight differences in how you can obfuscate a token between PowerShell 2 and 3 later. Here's a cool examples here, but again, we can't rely on a token. Like if we're looking for square brackets char, we can't rely on anything looking like that with command line. So you do stuff like this. So, encoding, decoding. So this is all good and fun. Maybe some people make it this fun. I think it's really cool. Frustrating for a defender, but cool. But like, why does this even matter? Today, what are attackers actually using? Well, typically, they're just using encoded command. There's PowerShell gives it to them, right? That's exactly what it's for. It makes special characters easy. Basics are encoded. You don't have to specify an invoke expression. Does it automatically. This is what we see attackers using. And typically, you'll see these flags here, like not all, for no profile, interactive, the logo, window style hidden. This is the kind of stuff that we see. And typically, we'll see like window style hidden. We'll see like W and window. Like the common. But obviously, this is not actually this is. There's a lot of options, right? Like we've probably seen a lot of these things being used. And for a lot of these things, you don't even have to specify it on the command line. A lot of commodity has gotten pretty good at basically saying, yeah, people are probably looking for execution policy bypass. So why don't we just change the registry key in command.exe before we even launch PowerShell, such that we don't even need to specify it on the command line. Or maybe we'll just change, for PowerShell.exe, we want to show up as a 1 pixel by 1 pixel size, like way off in left field. And then I don't have to specify window style hidden because the user will never see it. You'll start to see these interactions before PowerShell's even launched, so they don't even have to specify this. But let's look at encoded command, because again, this is really, we see attackers using this all the time. So, encoded command, encoded ENC, ECE. What do you think about these indicators to detect any of these execution flags being used on the command line? We have white space, dash, encoded command, white space. This would catch these indicators, right? This indicator would catch these flags. It would, but that's actually not the only way to write those flags. Here's what PowerShell actually gives us. They give us encoded command, then they give us the shortened EC. And then what they unofficially give us are all of these, because it automatically prepends a wildcard at the end whenever you're doing parameter binding or anything like that. Is that crazy? This was maddening to me when I saw it. It's like, how many bad assumptions have we made until this point when they could have been using EN or ENC or ENCO, any substring in between? So, whenever you see a flag, just try lopping off some letters. You'll be amazed at the possibilities that are there. This is why we have stuff like nop, nani, null, because that's the shortest substring you can get with that being the only flag that is returned. So, in Invoke obfuscation, whenever you select whatever options you want, it takes all of the flags, it takes any known aliases like EP, but then it also puts in the mix a randomized substring of every possibility that will work. And it will choose randomly one of those. It'll then randomly order all the flags, and then randomly put white space in between the flags. Why? Well, because you can, and because there's even AV signatures out there that are keying on certain tools just based strictly on white space dash ENC space dash nops dash. That's crazy. As a defender, it's great because you still see people using that stuff, but that sucks. So we can do better than that as the blue team community, and these are all possible. So that's crazy. That's just using encoded command that PowerShell gives us, right? You can also use .NET, right? We've probably seen this, convert from base 64 string. That's an option. What about like other encoding? Like ASCII? It works. Are we looking for that? Are we looking for hex, octal, binary? Bitwise XOR actually is being used. If you're not looking for that, there could be some fun stuff out there you're missing. But again, other ways to encode commands that gets rid of weird special characters that may be problematic on the command line, but it's not encoded command. It's not .NET. Again, these are all options that are out there that are possible, they work, but are we looking for these kinds of functions? And for a lot of these, like -join, -bxor, you don't even need a white space before and after it. So again, anytime you're making an indicator, just be super paranoid and say, am I absolutely positive there will always be a white space before this? Am I absolutely positive there will always be a dot prepending this? And then try all the possibilities to try to break that assumption. And if you are able to break that assumption, that's awesome. You've saved yourself potentially making a really bad assumption going forward. So what about something different for encoding in PowerShell? So how does PowerShell deal with passwords? Well, there's something called secure string. Does anyone recognize this command? Oh, wait, sorry. Oh yeah, but you know the whole asterisk thing, so that actually returned as secure string. So you can have fun, right? You can have fun on the command line. So with secure string, you can basically read in interactively, or basically force and say, read it on the command line, my password, and then convert it to a secure string object, which we see there. Then we can convert it from a secure string object and get this plain text value, which will start with this 0100 blah, blah, blah. Whenever you are using secure string and don't specify a key, it will automatically use your username and a computer name and use DP API. That's what it looks like. So again, have you ever looked for this substring in registry or in files or across the network? It's in a lot of places. But the whole point is, it uses the user and the computer name to make it difficult for you to steal my plain text secure string value and be able to use it on your system. You totally can if you grab the right artifacts, but that's something for a different day. So again, this works, but what if we don't care about the fact that I actually want it to work on your system because I want to use it as a way to launch something on your system. So if we use a key, then it actually uses AES, 16, 24, 32-bit, depending on the size of the key that you pass it. Now the size limit, we're all security people, right? We should probably feel pretty good about our passwords. Does anyone feel like 65,000 characters good about their password? Is that not insane? Why is that so big? Whose password is having trouble in a secure string object? So what if we put I don't know, a script or a command in a password object and use that as a vehicle? That's what I did. So basically, I took just a command syntax, put it into a password object with a key, all right, on my system. Now, I can run on your system that password object. Again, rip it out in not plain text, but starting with this big blob of data right here. And again, no matter what the key is, no matter what system you run on, it will start with this substring right here. So if you write a network signature looking for that string, it may surprise you how often you see a secure string blob followed by a dash key syntax with the key literally flying right behind it if you see command line arguments on the network. But again, I can run this on a remote system just like that, and it works. So now I just got AES encryption, and I didn't have to specify any of the AES encryption functions on the command line. Who's looking for secure string on the command line as an encoding, really an encryption mechanism? But it works. This one grows in size significantly. So in Invoke obfuscation, if you want to select to basically wrap your command as a secure string object, it's going to grow significantly. So you may want to do that earlier on in the process when you start to layer your obfuscation. But again, if you have a 65,000 character script, it's going to take I don't know, maybe 30 seconds for that sucker to unwrap, and your CPU is going to spike. So if you really want to set a huge script, then you could do something I don't know, maybe chop it up into a lot of substrings and secure string every one, and then throw it up on pastebin with the common delimiter, and then on the target, you can say, hey, go download this payload, split it on the delimiter for each item, unsecure string it with this key, piece it back together into the plaintext command, and then invoke what's left. So after I did this POC, I was really pumped. I thought it was kind of cool, and then I was going through TechNet looking for something totally different, and I came across this post from 2010 where someone said, hey, is there an obfuscator for PowerShell? And this guy responded, I guess you could cobble something together using secure strings to store the script. And I was like, oh, man, that sucks. I really thought I had something original. I was pretty bummed. I went and told my boss, I was like, hey, I still think it's a cool idea, but like, I mean, clearly this guy kind of had the idea like, 6 years ago. And he looked at it and he said, dude, this guy got 0 upvotes. You're good, man. But in all seriousness, the guy is just Carl, and he's like a super rock star on TechNet. So kudos to him. Really cool that he had that idea 5 years ago. So good stuff. Nothing's truly new in our community, right? So last, launch techniques. So we've looked at obfuscation, right? So let's say we feel super solid about our regex and being able to catch on the command line all this stuff happening that we just talked about. And we're applying this logic to every time we see powershell.exe running. Are there any problems here? There's some big problems here. And I'm going to say the one thing I'm not going to talk about is unmanaged PowerShell. Now, if you don't know about this, go look up Ben 10's talk on YouTube, and he does an excellent overview of this. So basically, PowerShell.exe isn't really PowerShell. PowerShell is system management automation.dll. PowerShell.exe calls that, but you can call that from a lot of different places. Projects like unmanaged PowerShell, Jared hates PS attack. Like, there's a lot of projects out there that do this so that you can call PowerShell commands and PowerShell.exe never runs. When this happens, PowerShell logs capture everything, but PowerShell.exe never runs. That's a big deal to be aware of, but that's not even what I'm talking about here. What I'm talking about is convoluted ways to launch PowerShell.exe such that you're kind of like abstracting or obscuring the arguments, and we'll see what that looks like. So typically we'd see what? Command C, PowerShell, and then the rest of the command. So what if we echoed it into PowerShell and then ended it with a dash? Or what if we invoked the $sign input? Does anyone know what those are? That's for standard input. PowerShell has built in this way to take the command as standard input. And when you do that, PowerShell.exe's arguments don't show the command at all. They're in the parent. Who all is looking for for all the stuff we just talked about, who all is looking for that in PowerShell and the parent process? Because it's possible, and it's being used out there. You could also basically store it in an environment variable and then spawn in a PowerShell process to say, hey, execute the contents of that environment variable. You'll see a lot of commodity malware doing this. Kofter is one that we see quite a bit. So if you ever see PowerShell IEX inv random variable name, that's something to look into. What set that variable? What are its contents? And there's a lot of different ways you can retrieve variable information through just that syntax right there. You can also do the same with clipboard. Again, setting it in one process, calling it in another. So in theory, we could say, okay, we're going to look for all these terms in PowerShell.exe and the parent process, right? And we'll be good. No, it's not that easy. What if we introduced a third process into the mix? What if we did that? Command to set the PowerShell command, another command to echo the PowerShell command into PowerShell. PowerShell runs the standard input. Well, this works, but when I looked at it, it's like, oh, well, the arguments still show up in the parent process. So what I did was went back, and this is where the fun comes in, where you have to start doing layered escaping. So if we escape that pipe for the first command, it's then not escape for the second command, so it's only applied to the second command. And when you do that, the arguments aren't in PowerShell or the parent process. They're in the grandparent process. And there's literally nothing stopping you from pushing this as many processes back as you want. So again, when you're choosing launchers in Invoke obfuscation, any launcher that has a ++ after it will push it up to the grandparent process. Anyone that has a plus after it will push it up to the parent process. I figured 2 layers up was enough to kind of prove the point, but again, we can't rely on the arguments even showing up in PowerShell. Here's kind of what it looks like from an outline perspective. We can't even say recursively that the arguments will always be in a related parent process. Again, using the clipboard example, or this one we actually have seen in the wild using WMI, the attacker basically sprayed his commands in a lot of his or her commands. Basically sprayed the commands into a lot of different processes, used WMI to query out the arguments of that process, pieced it back together, and then invoked it. Totally unrelated processes. So, a quick demo. So Invoke obfuscation is on my GitHub, and I actually just pushed version 1.4 this morning for BruCON and added a bitwise XOR encoding function to the string functions there. But basically, you just import the module and then run Invoke obfuscation. I'm a huge fan of ASCII art, and I love colors. So I hope you enjoy the colors in the tool, because I spent way too much time on it, but trying to make the interface usable there. So starts out with a little help menu. Basically, yellow options will take you to another screen, and green options actually do something. They actually apply obfuscation or launcher or something like that. So the first thing we need to do is actually set our payload. This can be a command, so we'll do set script block command, or set script path, which can be a local or a remote location for a script. So all the stuff we just talked about, you can apply to a command or an entire script. So we'll just copy and paste this example. So we're setting our payload just to a simple write host, just so we can see it works. And again, once we want to start applying obfuscation, we have our menu down here, token string encoding launcher. When it comes to navigating the menus, we can use back or cd ... We can also use home or main to get to the beginning. So in this example, let's go to the encoding menu and then type 5 to apply the secure string obfuscation. So we went to the encoding menu. Again, our green options actually apply obfuscation. So we select 5, and it randomly chose between, I think this actually has 3 different ways to do secure string syntax. It'll randomly choose that. Again, randomly apply white space. Basically, anything I could randomize, I tried to randomize. So we can also run test or exec to basically run locally the command. You may not always want to do this, but it's just nice to see, does this thing even work? We can do reset to basically remove all the obfuscation or help for the help menu. So if we run show options, we see there's our original script block. Here's all the obfuscation steps we've applied, and then here's the currently obfuscated command that we have. And the length is important, again, if you're wanting to paste it in the command.exe. So we can go to home. We'll remove obfuscation. We'll go back to get a little more advanced command. So we're doing our remote download syntax, which actually works for a local file, and I do this because I don't really trust anyone in this room, so even my demo doesn't reach out to the internet, but it works if you have a remote location. So our remote download cradle, let's break this down. So we have all these options here. Let's look at string. Well, remember in our example, the URL is a string object. So if we go into the string menu, we have one option, which is basically inline concatenation. So we can select that. And actually, the current version has the format operator as well, where you can, option 2 now, which exists, where you can basically start reordering all this stuff. So we obfuscated the string. So now we'll look at command, which we have 2. We have new object, and we have invoke expression. So when we go into the command, we have 2 options, ticks or splatting. We'll choose 2. Now, both of those are splatted. It randomly chose to use the dot or the ampersand invoke operators. It randomly concatenates. It randomly chooses the double quotes, single quotes, randomly puts white space between everything, randomizes everything that it can. So we'll look at argument. So net.web client is an argument token. And again, we go into the argument option, and there are our options. So we'll choose 2 ticks. Next, we'll look at download string, which is a member. And again, we'll see our options. We'll select our favorite. And in this example, we've now obfuscated download string. And again, it actually introduced another member, this .invoke. It's not actually necessary in PowerShell 3 or later, but again, this tool is meant to work for, the payload to work for PowerShell 2 and later. So that's what it does. So sometimes you may actually want to run the certain obfuscation more than once just to make sure you're catching all the elements. So now we've obfuscated .invoke as well. So everything has been obfuscated in this command, right? So we test it, good, it still works. We can run clip to copy to the clipboard. We'll paste it into a PowerShell prompt. It works there as well. Awesome. That was kind of it took a long time, right, to go through each element and to figure out what are all the elements that are in there. So we'll see a shorter way to do this in a second. But as we see in the script block logs, the command itself is still showing up obfuscated. The payload that it ran is not obfuscated, but you could totally obfuscate both the launching command and the payload itself. No issue there. So let's go back, and again, we'll reset all the obfuscation, but we could, instead of figuring out all the elements of the command, we could kind of just go to that all option at the bottom and just hit 1, and it'll go and randomize everything we just did, just like that, and you can do it as many times as you want. Start to see how it can get crazy, right? So let's go back to the home menu. We just looked at string, or we looked at token. We can look at string and basically concatenate or reorder or reverse. And again, for each of these, it will choose the random syntax options that I found to be possible, and it'll randomly choose which one am I going to use in the output. So you can see that there. I'm actually going to fast forward just a little bit. Some more interesting stuff. So encoding. Again, we go here, and again, the release this morning actually includes option number 6, which is bitwise XOR. But again, here's all these encoding techniques you can use, just applying each one by one. So again, ASCII, hex, octal, binary, secure string, and again, testing each one just to make sure, yep, it still works. So let's remove all the obfuscation there. And then I believe we're going to look at launcher. Yes. So launcher, again, after we've obfuscated, you don't even have to obfuscate if you don't want. Launcher is basically taking your PowerShell command and saying, all right, now I'm going to wrap you in something else to launch you in a weird way to obscure those arguments. There's actually quite a few more launchers in the tool at this point in the past couple weeks. I've been doing a lot of coding on airplanes here recently, so we have PowerShell command, environment variable, standard input. We have the clip and clip plus plus options now as well. But basically, you select which one you want, then you have your options here, and just selecting all the numbers of the arguments you want, and again, it'll basically choose a random substring of each of those arguments, randomize the order, randomize the white space in between it, put it in, and there's your command. Now, if you try to perform additional obfuscation on this command, it'll basically say, like, whoa, like this isn't just PowerShell anymore. You've added a launcher to it, so you need to undo that obfuscation if you want to do more. You need to undo the launcher if you want to basically do more obfuscation there. But I'm going to go to the very end for the grand finale. Basically just going through and showing that, yeah, like when you run these launchers, you can see that PowerShell doesn't have the arguments, the parent process doesn't have the arguments, you have to go find the grandparent process and it has the arguments. So we'll go back to the very beginning, and as the closing, we'll basically reset all obfuscation. We'll go to token, we'll go to all. We'll do that, I don't know, 2 or 3 times, hit all the tokens, all right? We'll go back. Let's do string obfuscation. So treat the whole thing as a string. We are going to then go to encoding, and we're going to basically cast everything to hex. We're going to test it. It still works. Let's go back to the home. Let's go to launcher, and we're going to do something like, I don't know, standard input plus plus to move it to the grandparent process. We'll put in our execution flags, grab it from the clipboard, go back to command, and it works. So even the tool and the demo are saying, please obfuscate responsibly. So that is my disclaimer. Please do not use this tool for evil. Please use it for good. So this is how I felt finding all this stuff. And there are still days where I feel like this. And I assume that maybe some people in this room feel this way. All hope is not lost. At the end of the day, why am I a cruel person for talking about this? Everyone's entitled to their own opinion. My heart is, again, I'm a blue teamer, and I want to help blue teamers. And attackers are already obfuscating, and this is possible. Even though we've not seen them obfuscate to this extent, syntactically it's possible. From a language perspective, it's possible. These are all options we have to be aware of. And a purely command argument approach is going to be insanely frustrating. I'm not going to say it's impossible, but it's super difficult if you don't have the amazing logs that PowerShell has given us. Super logs. If you're in an organization and you've been pushing for improved visibility in PowerShell, then I hope that this talk and this tool empowers your cause to say, like, here's why we need this logging, because commands can start looking like that, and trying to detect that on the command line is going to be insanely difficult. So break all assumptions. As a red teamer, as a blue teamer, we need to say what's possible. And again, does there have to be white space here? If we're not sure, we need to test it and see. Otherwise, I don't want to put that in a signature or in a trigger because I could be making a bad assumption. Know our options. What's possible? We have to be exploring and playing around syntactically with what's there so that we can make better judgments and better indicators. And finally, we can't just rely on looking for known bad. We can't just rely for looking on all the ways that we can do a remote download cradle. We have to also shift and say, what's weird about this? What indicators of obfuscation are there? Again, how many tick marks do we expect to be on a command line? Or dollar signs or anything like that. There's tons of opportunities here to detect this. We just have to be aware that it is possible, and we have to start looking and testing, and I hope that the tool helps with that. And with that, I'd just like to say thank you to the great colleagues I get to work with at Mandiant, some great colleagues from the past, previous employment, and also my wife, Paige, because she has supported me this past year to let me put in hundreds of hours of research, hundreds of hours of tool dev, at home, and that's not the most fun thing for her to do, sitting there watching me write code. And also she humors me by listening to me talk about PowerShell way more than I should, so definitely a big shout out to her. Again, here's my information. That's my talk. Thank you very much for your time, and yeah, have a great rest of the weekend. So thank you.